Hello, everyone. Welcome to this Tech Talk. My name is Raghu Prabhu. I'm a Global Business Development Manager for Data Lakes on AWS. Today, we're going to cover AWS Glue crawlers, and we're going to talk about some tips, tricks, and best practices to use AWS Glue crawlers in your data lake architecture. We have a lot of ground to cover, so I will be quick and hopefully not too quick. All right, so what's the goal of this Tech Talk? I really hope by the end of this Tech Talk, you should be able to pick the best use cases for the usage of AWS Glue crawlers. Next, understand the behavior of those crawlers, the input, the output, and why things work the way they do. Third, use the crawlers efficiently and cost effectively. And lastly, there are ways to accomplish the same goals as crawlers do, but without using crawlers. And I want to show you those means and mechanisms as well. All right. Some prerequisites. This is an advanced level Tech Talk. Some basic knowledge of big data technologies will be helpful, but not required. Some intro level knowledge of our analytics services as in AWS analytics services like Amazon S3, AWS Glue, Amazon Athena will also be very useful, but then again, not required. And some just data engineering background will also be very useful. What we got today, like as you can see, it's packed. We're going to talk about AWS Glue crawlers today. But Glue crawlers don't live in isolation. They sort of fit into the general AWS data lake architecture. So a quick intro on AWS data lake architectures. Then we will do an intro on the crawlers with the demo. Then we will talk about Glue crawler classifiers. This is kind of when we start getting into the meat of the topic. The different data sources that are supported by crawlers. Crawler behavior and the demo. Crawler is an algorithm. When you have an algorithm, it works and functions a certain way. So I want to demonstrate that to you. And then go into some of the best practices. How many crawlers do you think you would need? What's the best way to think about what's an appropriate crawler number for you? And then save money on crawlers. A few FAQs. These are some commonly asked questions by my customers. So I just preemptively put some FAQs and also a partner slide. All right. Okay, so introduction of AWS data lake architectures. This is a pretty involved slide, but I'm going to very quickly and very simply walk you through this architecture. AWS Data Lake begins with Amazon S3 as the storage layer, which is, if you're looking at my mouse pointer, it's right here. This is Amazon S3 is your data lake storage layer. And if you work back, there are two ways of bringing your data into your data lake. Batch load, and also streaming. And we have I have a couple of services here. We have other services too that will help you with batch load and also streaming. I've tried to put the most popular ones, the most common ones. EMR and Glue for batch load, Kinesis and Amazon MSK, Kafka service, managed Kafka service for streaming. Couple of different ways to bring data into S3. But what kind of data are you bringing into S3? You could be bringing structured data from databases, data warehouses, data that is predominantly in tables. They have a lot of structure. Second, semi-structured data. Semi-structured data, the definition of this is more where schema is either built in or it is implicit to the data, such as CSV, Parquet, ORC, JSON. They all have some schema built into them. That's semi-structured data. And then finally, unstructured data, which could be images, audio files, video files, documents too, can be your unstructured data. So all kinds of data can be brought in two different ways, batch load and streaming, into S3, which is your data lake storage. Once you land your data, that's kind of when you get to have fun with the data. You get to do analytics, query this data using Redshift, Athena, dashboard it through QuickSight, or you could do machine learning, using SageMaker and many of our ML API-driven services as well. So this is the quick overview at a high level what a data lake looks like on AWS. Next, this slide is in so many ways exactly like the other slide, but at a much lower level. We are talking about the services that predominantly makes most of our data lakes on AWS. Again, I'll go through this very quickly. It's the same story. This is your data, which is structured, semi-structured, unstructured data being brought into S3. The data on S3 resides as in multiple buckets and also subfolders, we call them prefixes, inside those buckets. And the data could be in CSV, JSON, Parquet, right? Many different, mostly open file formats. The schema of this data is captured by the Glue crawler. And this is the star of our show today. We're gonna, kind of have a deep dive about it in Glue crawlers. Glue crawlers will capture the schema and it will create metadata tables. We call them Glue tables inside the Glue data catalog. Glue data catalog is a metadata store, okay? So crawlers capture schema and metadata tables get created inside the Glue data catalog. Once the schema is captured, that's when you get to run queries using any of these services that you may already be familiar with. You get to run queries, you get to do dashboarding, machine learning, and all those things. But the part that is very important is the schema creation in the Glue data catalog. That is super critical, and crawlers play an important role, and that's what we're going to cover. And once you capture the schema, you really get to, maximize your investment investment in your data. Before we proceed, a quick shout out to Lake Formation. We are going to be using the Lake Formation screen, so I just want to mention what it is. It's a security and a governance layer on top of the Glue data catalog. So I'm going to repeat that again. Lake Formation is a security and a governance layer right on top of the existing Glue data catalog. So the tables that we are going to have in the Glue data catalog and the databases we're going to have in the Glue data catalog are going to be visible in Lake Formation, okay? Next, Lake Formation has a few goals. One of them is being that security and governance layer. Second, it forms a wrapper around S3, and we should probably have another tech talk on it. It reduces the complexity in S3 management, in S3 permission management. And so definitely check it out. It's called Data Lake Locations inside Lake Formation. So that's goal number 2. Goal number 3 is blueprints inside Lake Formation, which will help you in reducing the work in ingesting data from various different sources into S3. All right, so this is our, at a high level, description of all the major services in Lake Formation, in data lakes on AWS. But like I said, we're going to focus on the Glue crawlers today. So let's define them. What are Glue crawlers? I'm going to just read this off right out of the screen. A Glue crawler accesses your data store, which is mostly on S3, but there are other data sources too. It accesses your data store, extracts metadata from your data, and creates tables, which is metadata tables inside AWS Glue data catalog. So it is a metadata extractor, schema extractor from your data. there are really two goals for a crawler. Number one, create and manage glue table schemas, and create and manage partitions, data partitions in those glue tables. Two real major goals for a crawler, and we are going to look at a lot of examples while we do that. Before I jump in, I would just like to kind of give you a quick overview of what a crawler looks like, what it does, and then walk you through it. That's probably a lot better than me having to jump through a whole bunch of screens. So I'm going to go to the actual AWS console here. All right. So we are in lake formation. Okay, and like I said, lake formation is a security and governance layer right on top of your glue data catalog. So guess what? All these databases and tables are from the glue data catalog, as you can see. Okay, all right. So we're gonna look at some data, and we're gonna look at some crawlers. Okay, this is my S3, and I have some examples pre-created. We're going to look at my first example is Amazon reviews dataset. This is a fantastic dataset. Please check it out if you are to search on the internet for AWS, Amazon reviews dataset, something like that. You should be able to download this and play with this. So what I have done is I have downloaded about 80 gigs of data. I have close to 450 different files. As you can see, I have subfolders here, and we call them Hive style partitions. But these are nothing but subfolders. If I click on them, I'm in the apparel subfolder. I have a whole bunch of files. These are all review data, and they are just under 200 megs, so good sizable data, and they are all in CSV. Okay, so let's assume, insert your use case here. You get third-party data, you download data from your own tables, and then you put that on S3. It's going to look a lot like this, right? I'm going to click on one more location here. Same exact thing, right? Around the 200 meg file sizes and about 450 files. If I want to query this data, one of the first things I would have to do is create the schema of this data. So before I go into crawlers, let me show the schema of that data. In lake formation, you can create databases and you can create tables. And I'm going to show you one of these tables that have been created by the crawler. So this is the table that points to the data that we just saw, right? And scroll. It's a CSV, like I said. The location of this data, remember, these glue tables are metadata tables, right? And here's the schema. Here's the schema of that CSV, really. It had column headers. It pulled the column headers. It created this table for me. And like I said, I'm going to go into the crawler. And you saw this data is partitioned. As you can see, these are my partitions. And my crawler was smart enough to realize that the data is partitioned, and it automatically created those partitions for me. Perfect. This is great. Awesome. How did it do it? Here's the crawler that I used to create the schema for me. This is the crawler, and it only took about a couple of minutes to crawl about 80 megs of data. 80 gigs of data and 450 files. So it's fairly quick. So I want to show you this, but let me pretend like I'm going to create that crawler, okay? So you get to see this in action. Okay, we'll give it a name. And I want to keep this thing very simple. My resolution, I have increased my resolution, so you may see some overlaps, but it's just because I have blown up my screen, so it's a little more readable. So once I get past my introduction screen, what kind of data source am I going to be crawling? I want a new table. I want to create a new table, and I'll cover this part a bit later. My data sources, well, again, I'm going to cover this part a bit later, but I can crawl S3 data, which is what I'm going to do. I can even crawl relational data, even DynamoDB data, and this ecosystem is growing. All right, but first, S3, and my data is in my own account, so it's really easy. I can just browse to it, and this is my data, right? Very simple. I added my data, click next. I have a whole section on this. It's a lot of fun, but right now I want to keep this thing very simple. I just want to crawl one S3 location. That's it. That's it. A crawler is an app. Okay, it's a feature. It's an app. And as all things in AWS, when something needs to run, it needs to have security credentials. So I want this crawler to use this role. Okay, this role has permissions to the bucket. Click next. You can run crawler on a schedule if you want. Okay, right now I'm going to run it on demand, but you can run it on a schedule every 6 hours, and we can discuss that. We can discuss that, but just know that we do have options, so you can schedule these crawlers. All right, a crawler creates a table. Where does it create the table? These are the databases, and I hope you remember we created a whole bunch of I have pre-created my databases, and the table that we were looking at is in the Amazon Reviews database. So you can pick a database or create a new one real easy. There is nothing to a database. It's just a name and hit create, and you got yourself a new database. I'm gonna talk a little bit about this. I have a whole section on this, so I'm going to skip the explanation now. And I just want you to know that there is more to it, but on the surface, creation of a crawler is really simple. Just walk through a whole bunch of screens. And I have a whole section on this as well. But for now, what we are trying to do is really simple. So just take the defaults, click next. And if I hit finish and run, I get my table. It's really that simple. So quite simple, takes a minute to create a crawler, couple of minutes in this case to create my table. All right. So at a high level, that's how you would create a crawler and create this table that we just saw. Okay. I want to show you another example before we move on. It's we'll start with S3. Go here. I have an example subfolder, and inside that example subfolder, I have 3 subfolders. Person data. I got some person data. I made up some data, trying to keep it really simple. There is nothing to it. First name, last name, age, date of hire. Okay. I have a JSON file. I have an XML file. And I have a CSV file as well. Real simple, same data, but just the formats are different. And I have put them underneath, as you can see, right? It's really simple. What I did is I ran a crawler at the high level, at the example level. Okay, I ran a crawler at the top level and see what happens. What happens if I run the crawler at the top level? Let me look at the crawler too. I'll show you the crawler. Really simple. Scroll. Like I said, I have enhanced resolution, but that's good. Example crawler. Not going to click through the whole crawler here. As you can see, there is really no difference between the Amazon Reviews crawler and this crawler. I'm just have one path. I have one path that I'm crawling at the example level. What kind of data do I get back? Click on databases. By the way, that crawler ran fairly quickly. I would say, again, like a couple of minutes, maybe even less. 1 minute. Okay, so it ran for 1 minute, and what did it do? I have a database for this called example, and view tables, and I get 3 tables. Okay, so as you can see, there is a correlation between the number of subfolders I have had underneath my example bucket. Remember, I ran the crawler at this level. The crawler was smart enough to realize, hey, I got 3 different data formats, and therefore I'm going to create 3 different tables. There you go. I'm going to just click on one of them here. So you get to see there is really nothing. It's fairly simple. And here's my schema. Bingo, that easy. Cool, let's keep moving here. So I've shown you, I hope, a very high level overview of how to create a crawler, what happens when you create a crawler, you get tables. But one important point that I wanted to make in that JSON CSV XML example is this. I did not create 3 crawlers. Okay, I didn't have to create a crawler and add 3 different locations for 3 different subfolders. No, I just ran it at the high level, at the top level, and let the crawler do the job. Crawler does a fantastic job. It's smart. It's got all kinds of algorithms to figure things out and create those tables for you. All right. So one last bit before I move on. So you could have a top level bucket with 100 different subfolders, each one of them being a table. So we have customers who just run the crawler at the top level, and that crawler will go and create those 100 tables. But before you take this into action, I have a whole slide on how to think about table to crawler ratio. All right, let's keep going here. Let's talk about classifiers. Okay, so how do crawlers work? You have a crawler, and it has a whole bunch of data classifiers. For example, in the previous example that I showed you, it created 3 tables, JSON, CSV, and XML tables, right? Because it has 3 classifiers, at least 3 classifiers were used in creating those tables, CSV, JSON, and XML. It has other classifiers too. It has a whole database classifier, DynamoDB classifier, Parquet classifier. So my point is, a crawler has built-in data classifiers, so it can understand different data formats. So once crawler uses a classifier, it creates the glue table. But the world that we live in, if you're from data engineering background, the data we get is the real world data, and it's not perfect. Okay, it's not as pretty as the files that I showed you, right? You don't get it like that. You may have to sometimes tweak the crawler. Okay, in those cases, you can create your own classifiers, and I want to very quickly show you some of those things. You can create your own classifiers. And how many types of classifiers can you create? You can create CSV, JSON, XML, and also Grok. Look it up, even Grok classifiers, which are mostly used for fixed width files, so no delimiters. And if you want to still crawl it, how do you do that? You use Grok, all right? So when you take the built-in classifiers and add your own classifiers to it, you really, have a strong ecosystem of, your own custom classifiers to go with built-in ones to, crawl most types of data. Okay, so I'm going to jump into a demo here, and yeah, let me show you classifiers. Okay, right here, right next to crawlers, we have classifiers. If I click on a classifier, it asks you give it a name, it asks you what kind of classifier you want, and you input a few fields, and I'll show you an example, best explained with an example. I have a CSV classifier. CSVs are very difficult because, sometimes they are coded, sometimes it's not a comma, it could be another character like a caret. So as you can see, when it's not straight up CSV, it could be a tab delimited file or a pipe delimited file. If this is a pipe, just add a pipe. I think you get my point. Quoted, it could be quoted. What if your column has headings? Crawlers are smart enough, as you have seen previously, it will detect and create those column headings. But if you want to really make sure it gets it right, you can add those in as well. Trim white spaces, right? If your columns have white spaces and if it's going to mess up your data, and crawler gets a little confused because of it, well, we have a checkbox for it. So my point is, you can create, and by the way, the documentation is actually really good. You can walk you through XML, JSON type of classifiers. So my point is, when things don't, when your data is not exactly how you would want it, and you just want a little bit of help, classifiers are your best friends. I have a grok classifier, and like I said, the documentation is good. Check it out. Just click on this and you'll figure it out. But here's my grok classifier. One important thing that most people forget: you create a classifier, that's not the end of it. When you create that crawler, just make sure, this is my crawler intro screen, there is a section here for classifiers, and you just add them in. Like, I need to add it in. Most people forget that. Don't forget. And that's all there is to classifiers. So coming back to my demo here. All right, so we learned about classifiers, a basic demo on crawlers, how they create tables, some behavior of crawlers, and I have plenty more on crawler behavior. What kind of data sources are supported? Well, we have seen S3 in action, right? It can, AWS Glue crawler can go and crawl a Redshift table, for example. In that case, it doesn't move the data to S3. Data can stay where it is, but a metadata table can be created inside the Glue catalog by that crawler. Same thing for DynamoDB. Relational sources, we support Oracle, SQL Server, MySQL, Postgres, and then we are adding more data sources as well. So my point is, I'm showing you an S3 example where data resides on S3, but data doesn't have to reside on S3. It can reside in some of these other data sources, and crawlers do a fantastic job going and capturing data. Again, it doesn't move the data to S3. You can leave data where it is. You just capture the metadata inside the Glue data catalog. Okay, crawler behavior. This is my favorite section. I got a few of those. When I was creating my first crawler, right, I pointed out few areas where we're going to dive deep. This is one of those areas. We have a section called crawler, configuration options when you create the crawler, all right? And I just want to tell you guys what this is, because this is pretty significant. When you create a crawler, number one, why do you create a crawler? So you get a metadata table, and it also recognizes the partitions. If you are to rerun the crawler, okay, and if there is new data, crawler will crawl the additional data, and if there are any schema changes such as a data type changed or a new column was added, it will recognize those changes and it will update your Glue table. All right, it will update the Glue table. So it creates tables, it updates tables with new schema. It also creates new partitions and deletes partitions that are deleted. Okay, so it's a full management of the schema of the partitions. But chances are you don't want crawlers to go and do things and surprise you, you know. So what some of our customers do is exactly this. What I'm going to explain is when they run the crawler for the first time, they use this option. These are crawler behavior options. all right? The first option basically is the default option. Create the tables in the data catalog and update the tables in the data catalog. Then there is a second option is once the table is created, maybe you don't want the crawler to change anything in those tables and surprise you. But 80 to 90% of the time, the data only adds new columns, but you want crawlers to go and do that. In that case, pick the second option. And the third option is don't touch my table. Just keep updating my partitions. Do not touch my schema. Don't touch it. Just update my partitions. So I'll give you a use case how this gets used, right? And there are all kinds of use cases, and this is one of them. The first time the crawler runs, use the default option, which is update the table, create the table, do what you need to do. Most people, after the first table creation, they review the metadata, they like it, right? You can change it if you want. Either way, you get to review it, and you get to pick the second option, which is just add new columns from here on. Do not change my core schema. So you can use the same crawler, use it, and change the modes of the crawler. So that's my point here. So you get to pick what the crawler is going to do at any point of time. Then this checkbox, this is less used, but a significant feature. The schema that gets created, and this is very, folks who use a lot of Hive will appreciate this. The schema that gets created by the crawler is actually stored at the partition level, right? So if you have, let's assume the 10 partitions in a table, first 5 partitions have, particular kind of schema, say 5 columns. And from 6 through 10, you have a 6th column, right? The schema of those tables is kept at those partition levels, all right, which is amazing because you can continuously evolve your schema when the schema is stored at the partition. However, there may be some use cases where you just want to force a single schema across the board, across all partitions. That's your checkbox. It's not used a lot, but when you need it, I just want you to know it's there. Okay, crawler behavior. When I was creating a crawler, I kept my use case very simple, my example simple. I added just one S3 location. I did not add any more, but I did mention that I do want to explain a particular behavior. So I'm going to go into demo mode again and pick an example. Let's start looking at a data. All right, so back to my bucket. And we are going to look at example 2. In example 2, I have some CSV data. It's nothing crazy data. It's just very simple. If you can see my screen, I have the person CSV, first name, last name, age, and date of hire. And I have another CSV, first name, last name, date, age of hire with 2 additional columns, address and city. So I just have additional data. And for the sake of simplicity, what I have done is I have I've created 2 subfolders, female and male. In female, I have the person CSV, which means it has the basic data. And in the male folder, I have the other, it has the 2 additional columns, all right? What I'm going to do is I'm going to run the crawler at this level, at the example 2 level. What do you think is going to happen, all right? What do you think is going to happen if I just run the crawler basic way, the basic way? Let's take a look. So I've done that before. It's a really simple column. It's crawler. It is nothing different than what we have already seen from the crawler standpoint. I get a brand new table as example 2. I ran the crawler at this level. I get a table that says example 2. Click on it. Nothing's really weird here, but I get all my schema. As you can see, the crawler was pretty smart to merge these two additional columns, it was smart. It realized that it thought that this is probably one table, but two partitions. It's one table, two partitions, and it felt it needs to create those partitions, right? Create one table and merge the schema, because the schema is easily mergeable. So that's the default behavior. What if that's not what you want? What if you want something different, which is two separate tables? You want a male table, you want a female table. How do you do that? Same data. So I have an example for it. So just for the, as you can see, this is my crawler, just run at the top level, right? Now here's my new crawler. What I have done, this is my example 3 crawler. I have added 2 locations to this, 2 different locations, all right, to one crawler, and I run it. Now, what's the behavior? Click on database. I think that is what, example 3. View tables. There it is. So now the crawler knows that I'm getting 2 different locations, which means that I cannot merge the schema. I have to keep the schema separately, and obviously no partitions here. Keep the schema separately and creates 2 different tables. This is just to give you an idea how you can change the behavior of a crawler just by adding, the data locations. All right, I gotta go quick. We got a lot of ground to cover. Next, crawler behavior. This checkbox, what is the significance of this checkbox? This checkbox is actually very, very important. It says create a single schema for each S3 path, but what does that mean? So let's take an example again. Let's go up to my S3 bucket, and I think I'm on example 4. I have a folder and 2 files, just 2 files in there, person JSON and person JSON with added columns. So what do those files look like? Person JSON is really simple. You have seen this file before. First name, last name, age, date of hire, that's it. Now, person JSON with added column is very interesting. I got first name, last name, no age, no date of hire, and 2 additional columns. So technically the schema is very different. If I'm to run the crawler at the top level, right, at this level, what happens? So go to databases, and I think I'm on example 4 database here, view tables. I get 2 different tables, each table for a different file, okay? And this is not what you want, okay? You want one table, you want somehow crawler to figure it out. Hey, just give me one table. This happens a lot with JSON. You probably, if you run crawlers on JSON files, you probably experienced this. What happens with JSON is, as you all know, the fields that have no value are removed from the file, right? So sometimes you get a much smaller file, sometimes you get a much bigger file, but they are really all part of the same big schema. So you want the crawler to somehow group. You see where I'm going with this? You want the crawler to group all these different files and sort of like merge into one table. That's where this column is super, super handy. So I ran one of those crawlers just by checking the box. That's the only difference. And if I click on database here and go to example 5, that's it. One table. This is what you want. And guess what? The schema is an aggregate. This is what you want. So that, I just want to show you, like I said, tips and tricks, show you the behavior of crawlers and what some of these checkboxes mean, what some of these option buttons mean, and how the behavior changes. That's my goal. Okay, so that's kind of wraps up my demo, and I got a few additional slides on some of the best practices. So we're going to just try and cover that as quickly as we can. Okay, so how many crawlers should you create? Let's assume you got to crawl 1,000 different subfolders. How do you create one crawler? Do you chunk them out and create different crawlers? How do you do this, right? So don't take this as a golden rule. This is just a rule of thumb, okay? Use these 3 criteria with some other criteria that I'm going to give you to decide how many crawlers you think you need, okay? Number 1, owner of the glue table owns the crawler. So if a line of business owns these 15 tables, and if they want to use crawlers, well, they're going to get a different crawler than this other team, that other line of business. So owner of the table owns the crawler. Next rule, how often you run the crawler, okay? So not all data frequency is same. You get some data every 15 minutes, you get some data, that you would like to crawl every 2 hours, and so on and so forth, right? As you saw, and if you remember a few minutes ago, I showed you you can schedule your crawlers to pick up the new data, right? And so you're going to have to decide, this crawler is a 15-minute crawler, this crawler is an hour crawler, and you add those subfolders or prefixes that match to that frequency, all right? Third, crawler mode. What do you want these crawlers to do? Go and update the table and partitions all day, or not update the table, but just update the partition. So we talked about this. So how you want to run those crawlers will also decide what kind of prefixes or S3 locations or DynamoDB tables, right? Data sources that you want to add in the crawler. So start there. Few other things also matter. How many tables do you really want to crawl? Do you want one crawler to be responsible for 1,000 different S3 locations? I have seen those implementations. It's okay, it'll work, but do you really want one crawler to be responsible? So what do you have to, if you have to recrawl a particular table, table number 23, you got one crawler, So just kind of keep the blast radius a little more contained. Then how much data are you crawling? Is it like a terabyte of data? Well, use a few different crawlers too. I think that will help. You probably will get through what you need to do a lot faster. Finally, how many files do you have to crawl? You may be crawling just 100 gigs of data, but you may have 10 million files. That will slow the crawler down because crawler has to open each and every one file, or each and every one of those. There's no magic, a crawler has to open those files and look at the data to decide what kind of schema it has, right? So if you have too many small files, you may want to think about more crawlers. So these are just guidelines for you to think about. How do you decide how many crawlers you need, all right? Next, save money on crawlers. Crawlers are a pay-as-you-go feature. The longer they run, the more it will cost you, okay? So here are a few tips, and I'm going to go through them really quick, but these are important. If the schema is not changing, and if no new partitions are being added, don't run the crawler. My point here is, if you say you control the schema, right? It's not a third-party provider, you control the schema, the schema is not going to change, or when the schema changes, and you're adding new data, run the crawler once and create the table, and you don't have to ever run the crawler again. Save some money there and not have to constantly run the crawler, say every hour, when the schema is not changing, or when the schema changes. So don't run the crawler. Run it once and don't run it again. Or run it when the schema changes so it can go and update the table. That's it, right? So that's one way of doing it. Second, and this is my favorite, if you have 1 million files in your S3 location, right? One of your person's table, you got 1 million files. And if you know that all these 1 million files have the same data, the crawler, like I said, has to go and open each and every one of those files to see, what schema is. Just don't have to do a million and do the same thing when the outcome is going to be not different if it crawled 10 files or that million files. Same outcome, guess what? Put 10 files, have the crawler crawl it, let it create the table. Now you can bring the other rest of this data back, or however you want to do this. But just bootstrap your data lake. I call it bootstrapping action, save money. Use little data, create your tables. The tables are going to probably be the same. Now you can bring the rest of your data. And this only works if you know the schema is just the same thing across the board. Save more money. And this is, I call them use no crawler, which is you don't have to run a crawler to create the glue table. There are many other ways to do that. Glue data catalog is Hive compatible, which means you can write a great Hive DDL statement to create the table and accomplish the same exact end result. So no crawler, you can write a DDL, create table statement, run it in Athena, run it in Spark on EMR, same outcome. Or we have APIs. We have create table APIs, Poto, write a Python script or anything, just create the table. Same exact outcome, you don't need a crawler. Manage partitions. Our customers love running crawlers to manage partitions. It's awesome because it just works and you don't have to think about it. But if cost ever becomes an issue, don't run the crawler to manage partitions. As you land objects in your S3 bucket, you could probably trigger a Lambda and see if you just added a new partition and call create partition API, same end result. I love number 5 and number 6, they're my favorite. Let's assume a crawler creates a table, okay? If you go to Athena, this is just a Hive DDL statement. You can go anywhere. If you say show create table with the table name, it will give you the create table statement for that table which crawler created, which means you can take that create table statement and you can copy that and paste it in the test environment, paste that even in production environment. So you can use the crawler to create that initial schema and then just use show create table statement, extract the schema, and now you don't have to type it, right? Let the crawler create the first schema for you. Now you just get to, script it out and push it, for your deployments, right? 6th, same exact thing. So you scripted your table. Crawler didn't create the table, but you still want the crawler to manage your partitions. Not a problem. If you remember one of the first screens, it says, I think, new data sources or existing data source. In that case, you can pick an existing data source and attach a new crawler to an existing table and just have crawler manage the life cycle of that table, either schema or partitions. Not a problem. So even if a table did not originate from a crawler, you can use crawlers to maintain and manage the schema, partitions, and the life cycle of the table. All right, we are coming to the end here. These are some of the frequently asked questions, right? Chances are I may see some in the chat, in the messaging window here. How many DPUs a crawler uses? Right now we use 2, and this will help you in calculating the costs for your crawler. But this can change, so don't bank on it. We got plenty of ideas. Obviously, all our systems are changing, but right now we use 2 DPUs behind the scenes when we run a crawler. Can you configure, the number of DPUs? Can you say, hey, use 20? No, not at this time. Like I said, again, as all things, right? It can change. Oh, here's the number 3 is an important one. I get this all the time. If you have 100,000 files, you run a crawler, all right? Crawler creates a table, and you add 1 million files to it. No. You got 100,000 files, you create the table, you add 10 more files to it, and you run the crawler again. Will the crawler recrawl the million that it has already crawled, or it will just crawl the 10 net new files? It will only crawl the 10 net new files. We have bookmarking in the crawler, and it will not recrawl all the files again. Number 5, Can crawlers crawl an on-prem data source? Yes, we support all these databases. And I have if you can see this, here's a great blog post on how you can have, a Glue data catalog and crawler on AWS, but you can go into a data center and crawl an Oracle database, not a problem. Do crawlers, number 6, process the entire file? No. So if you have a really large JSON file, a 10 gig JSON file, we only sample parts of this data. We don't go through the entire data, okay? So we sample data and we roughly pick about an MB of data or about 1,000 rows to decipher the schema of this data. We don't crawl the entire file, all right? Not at this time. We don't crawl the entire file. However, like I said, if you have 1,000,000 files, we will go through the whole 1,000,000 files, just not, if these are bigger files, we will not go through the entire file. We will limit it, like I said, to 1 MB or 1,000 rows in that file. Lastly, you have seen this slide before, and as all of this makes sense. But I just want to call out that on top of crawlers identify the schema, Glue data catalog is your metadata store, and everything is driven off of this metadata store. All these services, which are AWS services from Glue, Athena, EMR, Redshift, Spectrum. I just want to call out that we have great partner support. All these partners here have also built integrations with the Glue data catalog. So the ecosystem is not limited by any means to our own services. All this goodness, you can bring some of your popular third-party, partners, providers, and use all these things that we have built, especially the data catalog. And that's it. I'm ready for some questions. Thank you so much. I hope this was not too rushed and useful. I really appreciate your time. Please, don't forget to rate this Tech Talk, and thank you so much for your time.